what's of interest to me is first the interactions between light and matter in the ocean, because light supports life in the ocean, because it fuels photosynthesis, especially of phytoplankton, which is at the basis of the food web. And as you know, the ice pack is being receding in Arctic, especially in summer, which allows more and more light to penetrate the Arctic Ocean, and which may support more biological production. We would like to know if it will support more biological production. So light is important for life, but light is also a vector of information. We can use light to detect things, to measure things. And we use changes in the color of the ocean to determine the concentrations of some substances in seawater, including phytoplankton, which means we can detect from space, in fact, from satellites, the ocean color and determine, based on that signal, what the concentration of phytoplankton there is in seawater. And thereby, we are able to monitor at large scale over long time periods the changes in phytoplankton biomass. As you know, there's a lot of changes occurring in the Arctic Ocean as a result of climate change. For instance, the receding in the ice pack. There's an increase in the fresh water discharge from rivers, an increase in the UV radiation, an increase in air and water temperature. There's a lot of observed changes in the Arctic, and we would like to know what the impact will be on ecosystems. But to determine what the impact is, we need to better understand this system, which is to a large extent unknown. We don't know very well how it works. What are the important organisms living there, how the communities interact or the populations interact with each other, etc. So my first interest is really in collecting more and more information, basic information on how the system works. And to do that, we collect a lot of observations from research icebreakers, but also using new observing technologies. I already mentioned satellites, but we also use a number of new platforms that are deployed autonomously, so without the presence of men. For instance, we use unmanned submarines or underwater gliders or profiling floats, and all those platforms carry different types of sensors that collect measurements for us and over large areas and long periods. It's made of a partnership between CNRS in France and Laval University in Quebec City. CNRS, which is the Centre National de la Recherche Scientifique, is the most important research operator in France. So this lab is located in Quebec City, and it brings together 8 professors from Laval University and up to 6 personnels from CNRS. In addition, there's a number of engineers, technicians, students. So I would say there's about 50 persons working in that team at this time. CNRS and Laval University partnered to open such a joint international laboratory that focuses on Arctic research. While Laval University, because it's probably the university that concentrates the largest, the widest array of expertises connected to Arctic. And additionally, CNRS brought here scientists that come with very specific expertises that are not so common in Canada, for instance, on isotopic geochemistry. CNRS keeps on supporting the salaries of its personnel, and the CNRS scientists in Quebec City keeps on having access to French funding, usual French funding for research. It's the same for the Canadian professors who are part of TACOVIC. They keep on having access to Canadian funds. And in addition, there's a major project inside Tekovic, which is this Canadian Excellence Research Chair I'm holding, and which brings very significant funding from the Canadian federal governments and the Quebec provincial government.